Come back to school and she doesn't come.
What's that fireball?
Okay,
Fireball flavor.
so should I even take the time to explain what we did last time to tell you what's going to be different?
No,
Okay.
it's not gonna make a difference. I don't remember. It really was.
Okay. Well, the stuff about the unit circle, like none of this stuff is wrong. It's just even more complicated than what is here.
So it is wrong.
No, it's just
Let us forget it.
more. Just let us forget.
Just forget it.
Let's
Let's be real, on the AP test, I'm screwed because I will not remember a single thing of what we done last
Oh,
year.
no.
And I don't want to have to find it in the notes.
Like, we've taken our time with it, but I will not remember any of
This
this.
whole working job. It's not August
I know. Thank you.
and it's March.
It's
like,
March
that's
1st.
crazy.
Yeah, I didn't have to change any of the numbers.
That means in 30
From
days,
February.
it'll be a year ago.
Yeah.
I'm embarrassed for you. I'm just kidding. I didn't even really hear what you said, but I see that you're embarrassed.
Yeah, you're right.
Okay.
Okay, let's talk through this. What I said last time about the unit circle is going to be the same. When we get to this point in the problem, we've got to find two different values for t before we move on to the next step. The way that we did it in this case was incorrect because you do it differently based on which trig function you're using. So this is where we need to kind of change directions. After we wrote t equals tan inverse of negative 1.5, anything after that, we're kind of ignore for a second. Erasing, yeah. Okay, so I'm gonna start tan inverse, oh, sorry, t equals. So this is where I'm picking up. T equals tan inverse of negative 1.5. So we put this in our calculator, or at least I did, and then I told you guys what it was. And that wasn't a misstep. Tan inverse of negative 1.5. And let's go ahead and still round this to 5 decimal places. So we get negative 0.98280. Nope, 79. Sorry. So last time from here, we added full rotations to this number to get other values, which wasn't wrong. We just missed a step in there. We first have to get a second value for t. And the way that we do that is going to be different based on the different trig functions. So let's take a second to talk through that, and then we'll come back to this. So this is kind of a sidebar. We have one value for t. We need a second one before we start looking at the different rotations. But to get the second value, this step is going to be different depending on which trig function you're using. So if we have a function that's using sine, then we're going to do pi plus, it could be plus or minus. So pi plus or minus the first value. So when you get a value for your variable, if you are using sine to get the second value, you do pi plus or minus the first one. For cosine, it's 2 pi plus or minus the first value. If it's tangent, it's pi plus or minus the first value. Secant is 2 pi and cosecant is pi.
So why is it wrong?
I don't know.
It's a particle.
And then there's also cotangent. I could not find anything about cotangent in the notes that I use. I researched it, found nothing about cotangent, so I'm going to assume we won't run into cotangent doing these problems. We're going to fingers crossed that doesn't happen, I guess, because nobody can tell me how to do it.
First problem is right there.
Cotangent, of course, that would happen.
Yeah,
Exactly.
That would be,
Exactly.
I think you could do an educated guess and use 2 pi for sure. Okay, so in the problem that we're working right now, we're using tangent. We have our first value. To get the second value, we do pi plus or minus the first value. It's plus or minus because you want to eventually have positive angle measures, which when you take a trig function of a number, you're talking about angles, basically, the whole unit circle thing, you know? And then also, if you remember the beginning of this problem, we're looking at an interval between 0 and 10. And so obviously, from this negative decimal, we're going to want to add to that to get us into the correct interval. Yes. Yes. So to get our second value, we're doing pi plus the first value. We get 2.158880. Okay, so the two t values we have, using those, that's when we add 2 pi in. N is like 1 rotation, 2 rotations around the circle, and so on. But we want to be careful to stay within the interval that it's asking us about, because there's no reason for us to find values outside of that interval. That's going to be of no value to us. So if n equals 1, our first value for t plus 2 pi, if n is 1, then it's not really going to change. It'll still just be 2 pi, but I'll write it just for fun. But then we also have this value of 2.15880 plus 2 pi times 1. This is a different, yeah. For this one, we get 5.30040. I'm keeping it at 5 decimal places, but some of them are just rounding up weird, so there's a 0 at the end. For the second one, 2.15880 plus 2 pi, 8.44199. Okay, from here, if we were to set n equal to 2, what that's going to do is put a 2 where this 1 is. We might still could get it. Let's just test it. I'm trying to decide if it's going to be within our interval of 0 to 10, but I can't really decide. So let's just test it.
So when are we doing this with all 10 numbers?
No, we just want to go until we see that we're going to be out of our interval, which is from 0 to 10. We want our t values to be between 0 and 10. This one's almost, I feel like maybe this next one's going to be out of the interval already, but we'll see. Yeah, this one even gets out of the interval too. 11.58358. So I'm certain now that this one's going to be out of the interval, because we're starting with an even bigger number right here and still adding 2 pi times 2. So I'm not even going to go do that work.
Yeah, it should be between 14 and 16 around there.
Yep.
Just 2 pi times 2 is close to 12.
Yeah, and then plus the 2. Yep. Okay, so at this point, within our interval between 0 and 10, we have 3 t values. We have the 2 that we just got here, and we have this one here. Whoops, you can't see that. Right here, the 2.15880. The other one, our original one, is negative. So it's not within our interval. We don't care about that one. Now, these are all the values, all the places between 0 and 10 where our derivative is equal to 0. That's how we got here. If you go back to the work we did last time, we set the derivative equal to 0 to see when the money in the account is not changing. So our t values are the values that make the derivative equal to 0. That's going to give us the numbers to plot on our number line that then creates the intervals for us to test whether the derivative is positive or negative. So on our number line, we have 2.15880, then 5.30040, and 8.44199. Sorry, here it is. 3 values on our number line that creates 4 intervals for us to test. And actually, we can go ahead and add. We're only looking from 0 to 10. We don't,
Always be 0 to 10.
no, that's just what was given to us in the problem. It asks during the first 10 years which the account is open.
Oh, is this like further?
This is still example 2.
It's just really long.
Yes. Okay, so we need to try a number in each of these intervals. So those will be values of t. T equals 1 seems like the easiest number in this first interval to test, and we're plugging those into our derivative. So maybe we should remind ourselves what that is first. Oh, I don't know why I wrote it like that. I was looking at the wrong line. Nothing changes. I just moved the negative out in front of the 100. Negative 100 sine of t minus 150 cosine of t. So that's the derivative that we're plugging our values into. So this first interval, I choose 1. That seems easiest.
So where'd you get the, where's this thing you just wrote?
From our work earlier. We found the derivative first thing.
Oh,
Yeah, this is why I don't like just stopping in the middle of notes and then picking it up so long later.
Yeah,
Yeah.
I don't like it either.
Especially after a week, if it was one block to the next, that's feasible.
Yeah,
Not gonna remember this.
3 days later.
I'll talk you guys through the whole example when we finish. Okay, plugging in 1, negative 100 sine of 1 minus 150 cosine of 1. We get negative 165 point some decimals. Let's see. 19244. All we really care about is whether this is positive or negative, because the question that's being asked is, when is the amount of money increasing? So we know in this first interval, we get, I'm not gonna write that.
will you have to work like big long problems like this on the AP test? And how long do you have?
A long time. I don't remember.
I was like, not thinking about that.
Yeah, I'll be lucky if I get a 1.
I think to get the credit for this being an AP class, you have to take the exam. If you don't need this AP class, I don't know why you're in here anyway, but
Valedictorian,
Yeah, that's the only reason.
that's the only reason.
Yeah.
well, that means you need it to count as an AP class. So you have to take the exam, but I
We
mean,
don't have to pass.
no, you don't have to pass it.
So I can just like scribble something like that. Okay.
I would love you to try, but
Yeah,
Online, someone, she like,
whoops, this is,
dashes and the spaces and like the periods and all, and she used it to make a finger and like it flipped.
oh my, don't do that.
And she got like a 4.
Wow. Okay, let's choose a number in this next interval.
Just continuing on.
How about 3?
I mean, if that gets you to pass.
I doubt that that was the reason she got the passing score. She probably got the passing score in spite of that. All right, negative 100 sine of 3 minus 150 cosine of 3. We get positive 134.38687. All right, we got a positive for the second interval. A number in the next interval. How about 7? We get negative 178.78400. All we care about is that it's a negative. I think so.
Patterns.
So you're just picking random numbers between like this one would be between 2 and 5, basically. Something like that. You're just picking random numbers.
Yeah. Mm-hmm.
Okay, so like when we did P prime of 7, we could do like P prime of 6 or whatever.
Yes.
Okay.
Can't you do like 0.5? It's just easier to do whole numbers.
Yeah. I just try to choose the easiest number in the interval. Sometimes it doesn't really matter. Our last interval. We do get a positive 95.45769. This is the end. We just have to write our answer now.
Only took us 5 days to finish.
Yeah. So during the first 10 years that the account is open, money is increasing when, and we'll write some intervals.
buzzer?
Yes.